everybody for today's webinar by Mr. Niladri Mukherjee. This is the second in a series, so I think many of you would know about him. And his first session was very well appreciated by all the attendees. He's a well-experienced HVAC design engineer specializing in hospital HVAC, and he's been involved with projects in India, Bangladesh, and Gulf countries. And he's the part of the team preparing the standards for IVF, that is for assisted reproductive technology. And he's been an advisor for the design of a South African hospital in Durban and an Indian government-funded hospital in Nicaragua, South America. Mr. Niladri is also a widely publicized author on articles specializing in hospital HVAC and is published in India, Bangladesh, and the Middle East. So, of course, his actual CV is very long, so I'm cutting that short. So, welcome everyone, and Mr. Niladri, over to you.
Thank you. Good evening to everybody. This is a second part. What we are doing, we are actually will be talking about hospital HVAC design. Now, the subject is very complex nature and it is very large subject. Even I am associated with one of the Indian large company for training their contracting people and their staffs on the same subject, but it is taking a lot of time. Anyhow, I have received some mails from many people whom I know personally, few people I don't know. They want to know the TRR system, how it will be incorporated in cardiovascular thoracic surgery. I don't know whether it will be able to cover it or not today, but we will take another session for that. See, this is a second phase. So this program basically we are made for the HVAC consulting organizations and hospital consultants. But this is also helpful for the hospital project engineers, those who are making the hospitals. And also for the postgraduate mechanical engineering students, those who are interested to making their career in hospital HVAC or HVAC consulting career. And definitely the architects would be benefited from these types of program. Now what happens this is a very large subject, as I've been telling you. We are going into the level 2. When I was trying to make it for a webinar, how we can cover up by 45 minutes to 1 hour, I'm finding it is very difficult. So what I have done, I made it in 3 to 4 parts, even in the level 2. So we are going into the level 2. That's why I'm telling you. There is a part 2 way which we will cover up under the level 2. Last session, what we have discussed and what you have studied, these are the points you have studied actually. Understanding the misconcept in HVAC design, basic knowledge of psychometry chart, comfort application, adaptive thermal comfort, critical applications and HVAC design, basic knowledge of thermal inertia, time delay and thermal damping. So this is already covered up. Now if anybody have any questions, you can ask me in chat box. So we'll give a reply on the part 1. Our main objective today will be, one is a basic approach of hospital HVAC design, that is the hospital flow system. So I'm going to the part 2. So hospital critical zone, we need to understand very thoroughly, even for the consultant, contracting organization, what is hospital medical flow system. Now what we learn actually from today's sessions, one is hospital building load design and modulation and climate. I will explain you what is the meaning of modulations and design modulations. Second, we'll learn today hospital building load design and climate swing factor. Third, which we will learn hospital international design standard. Fourth, HBPI report, which internationally called HP squared 2I report. Understanding the hospital medical flow system. Classification of hospitals and HVAC design. Surgical room classification and HVAC design. Basic surgical room specifications under HVAC. This is a new terminology what you are hearing, but this is very common. It's become very common in hospital HVAC design. That is called dedicated cooling medical appliances. And finally, we'll cover up the BMT room HVAC design. So you see, these all subjects are not very easy. You know, if I start dumping you in a very short time, it will be very uncomfortable. So you have to give us some time so that the knowledge level increases. I'm going back to the again that earlier slide which I've shown you. India will be a very large market for as a hospital industry. It will be expected that as a corporate hospital by 2030, it will be 173.63 billion. It is only the corporate. I will explain you why this industry is growing. One is India is the climates, food habits, language, and the economy both are very favorable. So that this hospital tourism, medical tourism, it will favor the support the medical tourism. So naturally, we expect that we will be getting more and more consultant. Hospital HVAC consultant, contracting organizations would come and they will learn the subject. And if they all together, if we can do much better for the hospital and finally for the patients. Now see, there is a very common rule we find that in HVAC, that is the rule of the thumb. And most of the people don't go into details building load calculations and they go in a shortcut and do the rule of the thumb. But I might request to the consultant and those who are doing the design, even a contracting organization, don't do for hospitals. Please go through the basic engineering process, how a building load to be calculated, especially for this types of specialized applications. So, when we will be discussing this subject, we will find a lot of difficulties, some problems, but our objective is not to create problem. Our objective to give you solutions. See, this is a subject which last time we have discussed. I'm just touching I'm going touch and go. Actually, heating in India, it is basically people are talking about heat load of the building. Actually, basically, it is a cooling load. Heating means when you are adding heat to your building. I'm not going in details this part because already you have discussed that a static pressure and static loss. This is a very important thing in the design where I explained to you what is actually the static pressure means. Now, this one, differential pressure and room pressure also I've explained. But when I've been discussing about the surgery room design, the differential pressure and room pressure will come. So I will explain once more. This point, RH versus grain per pound, is extremely important. So I've already discussed. Now today when I'll be talking about humidity and the grains per pound, we will discuss this thing. So we have discussed again last time negative pressure, RH. Now, in case of India, we find the word called clean room, but actually it is not a clean room. Internationally, it is called aseptic room. Second and last one is a BOQ versus HVAC design. You see this chart is a psychometry chart where actually the design temperature is 24 for a surgery room or even any hospital room 24. Basically what is happening when we are increasing the temperature from 224, slowly what is happening, the RH curve is coming down. So it means the temperature and the RH, they are interrelated. That is we find from the psychometry chart. This how we to control the humidity and the temperature in a surgery room or a critical room of a hospital we'll discuss. So the most important thing is coming the hospital building load modulation. Modulation, why this word are we using? See, this cooling load and the heating load, actually they are together called in general thermal load. And in addition is coming the moisture load. Now when we have to modulate this, it means the building thermal load and the moisture load, then it is coming load modulations. It's a very big subject. It's also very complex nature how to incorporate moisture load in the thermal load. we'll discuss this thing. Now, RH and temperature. This is many people ask me these questions about humidity control or monitoring. If we follow the psychometric chart, how we find the RH and temperature? RH is basically a percentage. When we talk about the grains per pound, it's like actually is a moistures, container moistures. Now, what happens in case of RH when if we follow the psychometric chart? When the temperature is increasing, slowly RH is reducing. When we are reducing the temperature, then slowly what is happening? RH is increasing and going toward the condensation. But the content of the moisture remains same till it come to the condensation level or at the 100% level when the condensation start. So what actually in case of these types of critical room design, say surgical room, bone marrow transplantation room, all these rooms, this type of calculation with RH is not very effective for the design or for the patients, because we have to understand that we have to reduce the moisture if it does not come down to the condensing level. So this is a very important thing. It needs about a lot of time also to explain the RH and temperature relations. But whenever we will be talking about RH, if you say only the RH, this is not correct. It should be coming with a temperature. Because I know many medical appliance company, they say that people are not doing the right thing to control the RH, like Cath Labs and others. So they are also not correct. I tell them you have to tell that RH and the temperature together. Then it will be a meaning. So this is the psychometric chart. What actually you see. In case of hospital, you have to, for designing a hospital, the initial stage, psychometric chart to be followed. So what is happening? When you are increasing the temperature, you see this psychometry, this is the RH curve is slowly coming down. When reducing it, again it is going to a condensation. That is why I am telling that psychometry chart is very important for these types of critical building applications. Now, what I am telling you that RH and temperature. So if you fix up a temperature, say 24 degrees centigrade, but you have a high moisture content, it depends on which location. If you are in Guwahati, in a Shillong, the container moisture is much higher at 24 degrees centigrade. Same 24 degrees centigrade, you go to Chandigarh, you will find the moisture level is low. So, RH and temperature equation, unless we go together, this actually the load of the building and our objective will not be fulfilled. See, this is a real life example which we have done it for Delhi. So Delhi actually with this 52.9 C, you see 52.9 C, this was the temperature recorded in 2025. That is for the 3 days. Again, the temperature came down to 7 degrees centigrade. That was found in 17 degrees centigrade, for 17 days. Now, peak RH came in Delhi last year. It is coming around 89.2 at 8.30 minus 8:30 a.m. So this duration of this humidity in the month of August, it was 5. Now, as a consultant or a designer, if this chart you follow, when you are designing a surgery room for a hospital in Delhi, then what you will do? There is no standard policy for that. There is standard direction is that it is totally depending on the consultant's idea and his experience. Now, if I compare with this same chart, is a realistic chart of 2025 versus one is a hospital and another is a office building. Now, as a consultant, he has to take a call. What will be my peak temperature I will take? Whether I will go for 52.9 or I will take a 44 degrees centigrade, which is going for 37 days. Now, this is a very, very critical thing to take, and it is a very important decision to be taken. My suggestion is that let us not let us not mix up with surgery room, hospitals, or these types of critical applications with office building. which is primarily works on comfort applications. See, now, if we consider at 52.9 degree for 3 days, definitely it will be an expensive for a client because his investment will be much higher in terms of capital investment. Now, if we go for 44 degrees centigrade, naturally this investment, because of his investment, will be lower, because this is a very critical thing. But in case of hospital, we suggest, or in the surgery room or this type of thing, let us go accurately, because even in the 3 days, how we will manage? In an office building you can manage, in a mall you can manage, but in case of surgery room, where if the difference coming between 52.9 and 44, it is coming around, say, around 8 degrees centigrade. It is a big, it will be matter in a surgery room, ICU room, because you know these ICU rooms are very, very critical in terms of higher temperature and lower temperature, because all the cardiac problems arises mainly in a lower temperature, sometimes in a higher also. So this is a way, that is why I'm telling that it's called modulation. When a consultant will designing, he has to understand this, and with his experience, how we'll do that. So this is a climate swing. Now, you know, climate swing is one of the major and critical issue for designing a building, and mainly this types of hospital and other. What is a climate swing? You see, if you go to NBC, it is this Delhi area which we are discussing. It is called hot and dry. Here, actually, you will find the huge change of temperature. What you find 52.9, and again we coming at a 7 degree. For that, when you are designing, you have to incorporate both heating and cooling. Now, India basically is a tropical country. Primarily, it needs cooling. We are into the cooling, more we are involved in a cooling business. But in case of Delhi, in case of Chandigarh, where the temperature swing, climate swing is very high, and when you are doing designing for an hospitals, this is a very critical job. So you have to keep an arrangement for also heating also during the time of winter. Now we'll discuss this topic in length, that what actually happens if we don't consider the heating in this sort of hot and dry zone. So the climate swing is very important. So this is it's called climate swing factor. Now we are asking the consultant and the contracting people, please, even architect, whenever I'm meeting the architects also, I'm telling this, please consider this climate swing factor, very important, and mainly in case of critical applications. So this is actually building load modulations. So how we are considering the thermal load and the moisture load. I'm not saying the RH, I'm telling the moisture load. Now, if we can discuss on this subject, say talking about Chandigarh and Delhi, where the temperature from in a summertime is very high and winter is very cold, what may happen? You see this one, this is a real picture. I'm not saying that hospital name, it is in North India. I'm giving you a example, live example. In December, I was in one of the town of North India. Suddenly what happened? Temperature by 4-5 days, within a gap, temperature fallen. Even the daytime temperature came in on 8 to 9 degrees centigrade, and very high wind flow outside. Even in a bigger hotel, this is very uncomfortable because of sudden change of temperature. When I asked the hotel management that what is the heating capacity they have, or what facility they have, it is actually, the answer was very negative. It was not there. Now, same condition I was survived. That's not a problem. It's a temperature came around 7 to 8, 9 degrees centigrade in the daytime. Now, this is a patient you check. Is a North Indian hospital. Patient is using a woolen garment, and all these things are coming from his house. It is not supplied by the hospitals. It means very clearly means an ICU patient. It means that hospital, I don't want to mention the name, they don't have a heating system in North India when the temperature is coming down. this is extremely dangerous. I'm telling you, he's an ICU patient. Is another big subject. It will take a lot of time. There's a lot of cardiac vascular problem comes if the temperature falls who are having a cardiac problems. Now, this issue. This issue is very, very critical. So I'm requesting, to the all the consultant that in case of hospitals, ICU, please have both the systems, heating and cooling, and to be designed to be made very, very accurately. And another thing also I'm telling you that do not use electrical heater. I have also seen in North India ICU rooms they are using a heater, even in a surgery room also, because they don't have a heating system. They have a cooling system. Now, what problem may happen? In case of heater, electrical heater, your oxygen percentage will come down and carbon dioxide go up. So it is not at all accepted. Now, what is the solution? Now, the I met few clients, they told me that this is very expensive for me to making heating and cooling. So what actually to be done? You have to calculate the critical area where actually the heating support to be given in the winter. Like ICU. This is called ICCU. Intensive Cardiac Care Unit. Very, very not normal ICU. The cardiac patient needs a thermal support. Thermal support means not that low temperature. IPCU means Intensive Pulmonary Care Unit and surgery complex. So there are some small heat pumps are available. They can be added and attached with a different type of HU, dedicated HU, and can give these types of rooms warmer during the winter time. Now, another question also come that if we make insulations, so insulation also can give a support. These types of room, if you have a thermal insulation, definitely these problems will be reduced. But what we are requesting that not to use the electrical heater. Now, when I'm discussing about all these things, a lot of questions of spending energy and others, I've been asked by many green building consultant that as you are telling all these things, actually the building will be very expensive in terms of energy spending. See, for them, they will raise the issue that environment, they will talk about the energy spending. Now, EPR, I have mentioned you, just see the EPR, EPR or EPI. What is an EPR? EPR means energy performance ratio. It is the kilowatt of the building is taking per hour divided by built up area. Normally, 350, 300, 350, this is accepted. It's a good. But in case of hospitals, surgery rooms, all other areas, the EPR will be much higher. So it's a big question and it needs time to explain also. Because if you try to reduce the EPR of these types of critical areas and to make it more energy efficient, many problems will come. Now, my question is to the consultant, or if I don't know, the green building consultant, that EPR versus light management. When we are dealing with this in a pharmaceutical manufacturing or these are hospitals and others, EPR and light management should be compared and then to be decision to be taken. This is again, it's a very critical area, which is the EPR issue. This is a questions of energy spending. Now, when we are finding that so much of complexity, doubts, debates are there for energy spending, how an hospital to be done. Now, we have been talking to the consultant also to prepare a very primary report to the clients. Because what we are doing, I am not giving HVAC for the comfort. I am designing HVAC for the life support. So this is the prime thing. So we have to understand a person who is commissioning or designing a mall and who was doing a hospital, two different things. So if we can provide a small comprehensive report to the client with details that why an hospital should be like this way, Definitely, a client is always think about his capital expenses and their regular operating expenses. But these types of report, it will be built up a transparency between the client and the consultant and the commission and the contracting people. So we request anybody interested to understand this more about the hospital project information index report, we can show you how it has been done. Even in some of the Bangladesh, Myanmar, we have, even in Durban also, primarily the hospital came, he was a non-medical person. He's the person, the owner who has invested this. We primarily worked on this hospital project performance index reports, which actually the gentleman and his team understood how the hospital should be designed and to be constructed. This is a very, very, very critical for those who are not involved with the hospitals. Hospital flow system. Last time I have discussed that as the hospital industry is growing, there are many people are involved in this hospital. They are called hospital consultant or they are the hospital contractor. I find as I'm associated with them and others, most of these people I've discussed earlier, they are not coming from HVAC background or formal engineering backgrounds. But what is happening actually, staying with the hospital for a long, so they are understanding the technicalities of the hospital and hospital flow systems. Now, when I'm trying to bring some HVAC people to the hospital, he's finding uncomfortable because he's not aware of the hospital flow system, how an hospital works. Same thing. If you come to think about the pharmaceutical industry, a consultant, or if he does not know how a pharma manufacturing works, there are different type of pharma product like tablets, there is a liquid, gel. These are the product needs. The consultant should know how the manufacturing process to be done. Like the very typical thing in case of tablet manufacturing is the granulations. How a granulation and HVAC design are interlinked. Same thing. Hospital, a consultant who is want to be a consultant for hospital or want to be a contractor for hospital, she should know the hospital flow system thoroughly. See, now we are going into, I'm trying to explaining you that what is a hospital flow system, which is completely different from a mall, office building, or anything. See, there is a medical terminology and a communications. I have found that when a HVAC contracting person talking to a doctors, hospital people, there is a gap because he is not normally aware of the medical terminology. So the communication, there is a gap. So when he's talking about the details about the medical technology and others, so this is also a hindering factor in case of hospital designing and commissioning. But in case of hospital consultant, you say, they are more aware of the subject. They know how a hospital works. So they have a better communications with the medical practitioners, maybe at hospital management or doctors. This is happening in front of me also because I don't want to give you more this example of that, but this is very common. So my request to the hospital HVAC consultant to know the subject about the hospitals, how a hospital flow system works. Now see, I'm just giving a rough idea of the hospital system. It is called non-cancer medical system 1. Why I'm telling a non-cancer, I will explain you. Because cancer hospital needs or demands a different type of thing which is not fall under the general hospitals. So what we find, the emergency treatment system, OPD system, pathology laboratory and pharmacy. Now why OPD? I make a round neck, this round shape. OPD, recently I was talking with one of the hospital contract clients. So I was suggesting him that OPD don't neglect. OPD means a very unknown zone and it's a threat. It's a threat. Why I'm telling threat? Because external client, the patient coming, we don't know. and what disease they are carrying. Maybe there are some viral infected patients are there. What will happen? They will donate their infection to the air. Now, if you allow the main hospital air and OPD systems air together and mix up, and there is a chance of spreading the infections, because we don't know who are the patients. So this is a very critical area I am explaining. Then he has accepted also with a one-to-one discussion. I told him that bring the OPD system separately, air system, air distribution separately from the main hospitals. Second thing, you see, surgical complex system. I'm not sending surgical room. I'm using this word called complex systems, because one surgical room should have a their supporting rooms. That is why it is called surgical complex room. Another is ICU wards. This ICU is very specialized because there are different grades of ICU. Another is hospital MGS, medical gas systems. So how a medical gas system moves is oxygen, nitrous oxide. Now another thing is very important in case of hospital, that is a hospital fire system. Now all the electrical maintenance peoples and these engineering people who are involved with the fire, they're using a word, hospital do not burn. Why they are using this word? Because if any chance the fire catch up, it will be difficult to evacuate the patients. In case of hotel, which is also a 24-hour staying or guest stay, there the guests can be removed. But in case of hospital, it will be a problem. That is why hospital fire is very critical. Medical appliances supporting system. Now, what is the meaning of this medical appliance supporting system? Today we are talking in 2026 January. There are many medical appliances have developed. So in case of hospital, main improvement has come for the patient treatment. It is by the engineering. Medical appliances or medical gadgets or medical equipment, whatever they say, but in this formally it is called medical appliances. Actually, there are plenty of medical appliances come if we compare with 10-15 years, like cath lab, MRI, invasive ventilator, so many, PET scan, SWOT scan, so many products are there. These medical appliances are so highly dedicated that they comes with a sensor, and this sensor is inbuilt with the temperature and humidity. So need a very specific type of cooling or a dedicated cooling. So this is another support is required to maintain all your medical gadgets, medical appliances. Third, which is I'm showing, that is a central sterilized supply department, CSSD. Now all the big hospitals are using the CSSD. What is a CSSD? It is means whenever you are using the tools, in the different type of tools are used in the surgery room, through the black corridor it comes to a CSSD room. Is a central sterilized supply department. It is basically an electrical boiler. It is called an autoclave. Now this autoclave gives the two things. One, it generates its cleaning. It's the and sterilizing the products by the hot water. Simultaneously, this room become heated because it generates lot of heat. So we are working out that instead of giving the heat to the room, if there is any heat duct process is there, so that you can remove some of the heat outside. Now this is now very, very common in major bigger hospitals, and it's a sterilized room. It needs a 3 airlock minimum. Everybody cannot enter. So it is this, after the sterilization, it will go through a white corridor. So you understand, unless a person who was thoroughly aware of how a CSSD work, what are the demand and what are the terminology used for CSSD, it will be difficult for that person, HVAC person, to handle and design a CSSD. Along with that, there is a hospital kitchen system, hospital waste, biological waste is very critical. hospital housekeeping system. Now I'm using that hospital data center cooling. I'd been to September for a 1 day to Bangalore. They have called us some expert and others, a PE company of American PE company. They are investing in, they are planning to invest in some of the corporate hospital and networking. You see, I show you a chart. There are many corporate hospitals are there now in India, and they're further it is growing. They are all supported by PE companies. They are mostly an American company. They invest. Now, a hospital which is having a headquarters in Bangalore, there may be 20 hospitals there in across the country. They maybe have a server at their Bangalore and they have a sub server at a different locations. As the AI is coming in medical system, surgery. This is auto. That is the full robotic surgery. What is this? This is AI driven only. So generally that and hospital needs to keep many datas and data analysis are required for as the improvement of surgeries and the improvement of treatment going through the technology. So definitely there is a demand for hospital data center cooling. Either it will be a liquid cooling, or if it is not, or it will be air cooling. But data center cooling is a big demand and big challenge also coming in hospital segment. Now, whatever I've shown you, these are all non-hospitals, non-cancer. Now you go to cancer surgery, cancer hospital. Why it is special? Cancer hospital, one problem is immunity comes down. One problem. Second problem is patients having a psychological problem. So treatment of a cancer hospital, cancer patient is different from a general hospital. That is why we are finding the cancer hospital are coming separately. We are not mixing up. Now this chemotherapy, radiotherapy is a new technology has come. Is a radiotherapy machine, is a radiotherapy room is there where patient is giving a radiotherapy, but it has a problem. It is definitely a challenge to make a radiotherapy room because of radioactive contaminations. Stem cell transplantation. What is this? This is basically a bone marrow transplantations. Is a very special treatment of a cancer hospitals. I will explain you this stem cell transplantation, how the room to be designed. And radiostatic therapy. What is this? This is actually the medicine is made by it is called nuclear medicine, or it is called radioactive medicine. These are used for a cancer patient in a cancer hospital. Then they are putting into a PET scan. So this bone marrow transplantation is this is basically simply say leukemia. It's for the leukemia patients, blood cancer. So now treatment has come. But this treatment, the machine, along with the machine, this room will be successful. I mean, treatment will be successful if we can give a proper HVAC design. 100%. The HVAC design is wrong. Bone marrow transplantation process will be a very problematic for the patients. So that's I'm telling you, the radioactive therapy, this is a new thing which has come. There's a room which is to be kept separately for radioactive therapy room. There's a PET scan. It is also used for cancer hospitals, cancer treatment. So what actually I want to tell you that the hospital has its own language, terminology, and its technology. It's a medical technology. So if somebody wants to interested to come to become a consultant in hospital area, primarily should be thoroughly knowledgeable for all entire hospital systems. I'm finding because recently I was training people, contracting people who are in 14, 15, 20 years of experience in different projects. But I find it's becoming difficult because I spend them around 30, 40 hours with them. But I agree it is not possible for a person to work to get a knowledge within some 40 hours or 30 hours, but they have to continuously study the hospital flow system and understand how a hospital works. So this is a cancer hospital where the problem is the patient is having a psychologically down and immunity also come down. So treatment to an cancer hospital is completely different from the normal hospital. So this is called actually oncology unit. This is a cancer. Normally you don't use cancer. Medically it is called oncology unit. Now, how to design a bone marrow transplantation unit? I will explain you very slowly. What is a bone marrow transplantations? Bone marrow transplantation is, see, earlier, say around 15, 20 years before, if somebody is to have a leukemia, blood cancer, it means the blood cell becoming white. There was no treatment. It is a slow poisons and the patients used to die. But fortunately, we have found a technology where the patients who are having a leukemia or a blood cancer, it can be recovered. But how? It is not only for the doctors. It is not only for the doctor. It is also for the engineering which is supporting a blood for this blood cancer patients to recover from that this cancerous problem. Now, before going to a bone marrow transplantation, I will explain you how it is done. It's a very critical thing. In Tata, in Bombay, Tata, they have a bone marrow transplantations long time before, and they hired a consultant from Singapore because designing a bone marrow transplantation room is very difficult. So when you go to a bone marrow transplantation, we are talking about a cascade airlock. So this cascade airlock means the one side it will be a very high positive pressure and slowly it will be a lower pressure and lower pressure. This technology used for bone marrow transplantations. How it is happening? Before going again, I am telling you, let us understand what is actually the room pressure. Room pressure, say you see the picture, there is a wall 1 and wall 2. There are two pressures operating, X1 and X2 Pascal. Difference between X1 and X2 is the exhibit pressure, which is the delta P, which is actually the room pressure. But engineering way, if I tell, no, it is not that. There is a loss of pressure between the room. What is called? That is called load factor. This is a load factor means when between the two rooms, when you are designing a surgical room airflow and is pressure, because CFM is depending on the pressure. So it is directly related. CFM is directly related with the pressure. Now, what actually our design CFM, if we make that this is the CFM I'm making, so it will be the pressure. It actually, in true sense, it is not happen like that way. Why? Because you follow this equation, the delta P is equal to K into CFM square. What is a K? This is called load factor. When air is moving, there are plenty of instrument gadgets are there in a surgery room. Unless you consider this K factor of a surgery room, your design CFA, what you are taking, it will not have the same thing. Definitely there will be a loss. So that is why it is called the K factor to be added, where it is depending on the consultant who is designing. It is different. It is from room to room is defined. But I am very particularly telling you surgery room. Those who have been to the surgery room, they know that how many gadgets are there. So K factor is very important. So what actually I want to tell you from this equation, the room pressure is depending on primarily on CFM. Now this is, you see, this is called the BMT room. How the BMT room happens? What is the BMT process? Actually, there are three processes are there in BMT. One process is when the early rejection is happened. Normally, is bone marrow is taken out, and it can be recovered, and again it been it can be sent back to the patients. Second one is where take it from the closer relative where a DNA is closer by. Third is absolutely a donor. Now you see, this is the picture you are finding. This is a picture. This is the way bone marrow transplantation room where patient remain for 3 to 6 months. Everything he will not be able to go out. Now, what is a marrow? Bone marrow. The bone marrow is actually helps a human being or any living creatures for the immunity. So immunity support actually coming from bone marrow. Now, when you are removing the bone marrow, in immunity coming negative. So you understand a patient how critical it is. any small infection, small dust, small immunity thing comes to the room, that patient will not be able to withstand that. So his immunity is very, very extremely low. Or I can say minus. So what you have to do, this is a room, it is a zone which actually should be done ISO 5 standard. Absolutely 100% ISO 5 standard to be maintained. See, I'm saying it is supported by 3 airlock. Airlock 1, airlock 2, airlock 3. Now, everybody will not be able to enter in a BMT room. Patient remain there. So, what happens? A very special nurse and everything who are allowed to get into the BMT room with a clean race and clean ground and everything, they enters. Now the pressure in this is much higher. So whenever you are opening the door, some amount of pressure air will move this side, but pressure air from this area will not come to the BMT room. But this is a basic thing. It is not 100% correct. Now you go to second slide. This slide, you see, this is the drawing of a BMT room. This BMT room, this is our 25 Pascal we are showing, which is to be maintained. And there are different Pascals are there. 20 Pascal, 15 Pascal, 10 Pascal, like that. Along with that, a patient is continuously staying for 6 months. He is not going out. He has to give in a washroom also. So these are the washroom 1, washroom 2, washroom 3. How will do it? Now, washroom is a very dangerous thing. Any infection can come. Now, it is shown there are 2 HUs are there. This HU, it is dedicated to support your airlock. So these all are called variable air volume. So it means what is happening, this is with the sensor, this valve is opening and closing. Whenever a door is open, there will be a loss of air, and it means loss of pressure. So this sensor is like that. You have a magnesium gauge are there. Every door there will be a magnesium gauge. It will give a sensor so that the valve will be activated and loss of pressures will be supplied by extra air by the valve. So this is way that these 3 airlock to be continuously maintained, and the differential pressure between the main area, core area, BMT room and the airlocks to be maintained. Now let's come to this side, which is you are showing the washroom. 3 washrooms are there. These washrooms are again to be supplied by a separate HU. This HU is supplying the air to the washroom, and here this entire exhaust air, it is going back to outside. So it means what happened is 100% fresh air. It means we are these types of washroom, there will be 100% fresh air. So you see there are 3 HU. One is dedicated HU for the BMT room. One other HU is making for the differential pressure control, pressurization. Another HU which is 100%, it is actually 100% air is getting changed. This means SCHPH is 100% for supplying the this washroom 1, 2 and 3. And there it is said that there should be minimum, it is 15 Pascal difference is there, should be kept, so that any chance the air should not come from the washroom to the main core area. So you understand, this is and doors are electronically interlocked. That is another important. So you understand is how difficult it is, because managing and designing an air is much more difficult than a liquid. Both are fluid. In terms of fluid dynamics, both are fluid. But air is more difficult because under pressure it gets compressed, it changes its pressure and everything. Therefore, for a BMT room is completely depending on HVAC systems. Unless and until HVAC system is proper and monitoring and all to be under automations, it will be a real threat will come to the patients. Anyhow, whatever I'm discussing with you in a very short, but it is not so easy for designing a bone marrow transplantation room. This is a part of cancer treatment today. Now, let us talk about the basic surgery. See, when we talk about a surgery room, today it is not possible. We will discuss in other sections of classification of surgery. Now, one of the thing is we have to consider dry bulb temperature and wet bulb temperature both. And also you have to consider the wet bulb depression. Why? Because if we going, it is under the cooling tower, wet bulb depression is very, very important. RH and WG by pound, or it is a basically pound per, it is actually pound per grain is very important. Grain per pound. Now you see the sixth one. I don't know whether you are aware or not. Those who have seen the surgery, live surgery, they'll be able to know that if they have got an opportunity. Thermal plumes and surgical plume density. When you are using a surgery, they use a diathermy machine or cautery machines. This machine generate huge heat, and this is called surgical plume. And it can also found in a graphical way. I mean that how at the heat map also you can find how much heat is generated on the patient body. So when you are designing a surgery room, if you don't consider that it's surgical plume and its density, it depending on what wattage of machine they are using, it depending on the different surgery, different wattage of diathermy machine is used. This is very important, and its heat which is generated over the patient to be removed. This is a big challenge for a surgery room. Now you tell me there's so many surgery rooms are surgeries happening. Nobody discussing about the surgical fume density and others. I will not be able to give you answer here. If you can speak to me, I will. But what I will telling you, which is the correct process. So ACH means the air change per hour, which is happening. Air velocity is very important. Is actually air velocity and CFM or vice versa. Air velocity is very important. Room total pressure and room static pressure. Why I am mentioning the room static pressure? If there are two parts of the when the air moves or fluid moves, there are two pressures. One is a static pressure and is the velocity pressure. Now, if this portion that static pressure goes up, it is not good for the health. So you have to, we always ask the consultant when you are designing, find out what is the static part of your entire air flow. Because high static pressure, high static if generates in a room, it is not good for the health. CO2 level, that you know that carbon dioxide level is to be controlled. There are some ppm standards are there. VOC is another volatile organic compound. This is also very important. As I have discussed you, the differential pressure, static electrical diffusion rate. The static electrical diffusion rate, if you go to a mall or you go to an office, you go to the airport, this problem will not come. This problem will come these types of surgery room, where plenty of gadgets are there, where diathermy machines are using, they generate static electrical diffusion. This diffusion need to be removed by a very specially designed with the floor on the top of the floor by earthing. So that is a very important thing. When here actually the electrical jobs are there, a person has to understand what amount of electrical diffusion is happening. According the earthing has to be designed.
Excuse me, Niladri, we are only 5 minutes more.
Ajay, I'm cutting short.
Yeah.
Now what we will do, so this AS certification, I'm cutting short. AS certification is the one thing. You know my email ID, so people can ask me more details and we can discuss is that. AS certification is that room temperature gradient, which is actually in surgery room is called around, it should not be very more than 10%. Now this TRR is a word, full word. It is called temperature recovery rate. For this, I have got plenty of mails I have received to explain them how to design or incorporate TRR in a surgery room. So, as you know, we are very short of time, so I will discuss now what happens very shortly. I'm telling you, when we have a body temperature, that is a skin temperature and is the invasive temperature. So they are not same. When open heart surgery is happening or cardiovascular thoracic surgery is happening, your inner temperature become very cold because the doctors keep it around say 18, 20, 19 degrees centigrade. So when actually the summing up is happening, if you suddenly you sum up, and when a body temperature outside and inner is very low, there is a possibility of hypothermia. Now, that is why this type of problem happens in cardiovascular thoracic surgery. So there actually you incorporate a TRR, temperature recovery rate. So what we'll do, if we get an opportunity, we'll have a separate session on designing of TRR system in cardiovascular systems. So that is why I'm telling you, I'm closing it. I'm showing you this is a cardiovascular thoracic surgery room. HVAC design, incorporation of TRR facility. So I received many mail. Anyhow, we'll hope we will get an opportunity to explain you how TRR can be. But it's a big session. TRR exclusive session we will make for TRR. How to inbuilt in a surgery room, cardiovascular surgery room. In short, I'm telling you, this is actually called Society of Thoracic Surgeons. It's American. They under them there are plenty of surgeries, associations are there. They have developed a broad certifications and standard for these types of cardiovascular thoracic surgery. So now we do not have much time. As I have been telling you, it's a very big subject. It's very complex nature. So many doubts, many debates, many discussion will continue. But I'll definitely, if I get an opportunity, I will cover up this subject. It's a separate subject to inbuilt TRR in a cardiovascular surgery room. How a cardiovascular surgery room to be designed. I have explained you in short that a BMT room design, primarily on the air circulation, air pressurizations. So thank you. If you have any questions, you can ask me.
There is one question in question and answer box. Can you see that?
In chat box.
No, in the question and answer. I can read it out. It says during the monsoon season, how to maintain high supply temperature as supply air temperature is relatively low due to dehumidification. I don't know whether it makes any sense.
This humidity is a general word, but I have been telling you for a critical operation, critical applications, we don't say humidity, we divide in RH and we divide it with the moisture content, grain per pound. I have also explained to you the temperature and humidity or RH, how we interrelate, how they function in the psychometry chart. Now you have to find out the location. Now when you get into a place like Chandigarh, your humidity will not be a very threat. But if you go into Guwahati, you go to Dhaka, it will be a big threat because their temperature will not be very high. It will be around 35, 36 degrees centigrade in a monsoon, say in July. But your humidity comes around 85%, 80%. In Dhaka, you go to Barisal, all these places. So my experience is that how to incorporate, how to control the humidity. Now, humidity or the reductions of moisture, it is done by the condensation. Now the basic thing of physics is one is a latent load and is a sensible load. Now when you applying the compressing technology, what is happening? It is continuously compressor is moving and the air temperature is reducing. If we don't give any fresh air, that air in the room slowly it is getting lower and lower, and it come to a saturation, and it will definitely your moisture content of the room air will come down. Question number one. If we don't supply fresh air, now if the moisture content are high and your design temperature 24, compared to that's why I am always saying you have to mention the RH with the temperature. If you don't mention only RH, it will not work. So if you have a temperature of 24, but you are finding the RH is still high, then what will happen? There is a normal process, you have to generate heater. And if you that heating may be through electrical heating or boiler, some heating you will be heating. So what will happen? It will reduce the the compressor will not stop, compressor will continuously work, and your latent load will reduce. But when you are, this is the one process, because in health it is said the 55% RH is okay, good for the health, and it is also in terms of microbiological function, their activities. But in case of pharmaceutical manufacturing, that is, they with the raw materials are very, 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 hygroscopic. This is called kappa K. So it is, we to calculate what type of kappa you are using for the raw materials. They absorb moisture. For pharmaceutical manufacturing, it does not work 55. It is go up to 30, 35 also. That type, the vapor compression technology not will support. Then what you have to do, you have to use a parallel desiccant technology. So this humidity and temperature is a challenge. Always is a challenge, as I have explained you. It is depending on the location to location, a consultant to decide how I will design this thing. Any question? You can ask me, unmute and ask me.
There's a question says, is it possible to maintain different room pressure with use of same AHU?
See, this is one thing is that say there are 4 rooms, we have designed different pressure level. This is possible only if you have a valve system and a sensor. So it means that all the valves should be with a VFD drive. So this I mean this the fan should have a VFD drive. Unless we have that system and if we incorporate the sensor, actually this differential pressure maintaining is not possible. It has to be under the automation, because whenever you are opening the door, there is a loss of pressure. Further, there is a leakage also, that's called the door undercut. So this always through that there is a leakage, that you may consider that this is a pressure loss continuously happening. But when you are opening the door, there is a loss of pressure. So how will make up? So it means you have to supply air and to make up that. So whole thing has to be under automation. Only then whatever I am designing, a consultant, and that will be maintained.
Okay, I think anybody further queries can be sent to tgsupport@ishraehq.in, and I am sure you'll be happy to answer all the queries which are coming in. I don't see any further real good questions. Is it possible to maintain different? No, that I asked. How to find the positive? Can you see that question? How to find the positive is pressure maintained in OT or BMT as per design? I am not understanding that. Can you see that question?
1 minute. Questions. Audio. Slide. I'm not.
It's okay. We'll send it to you into the email. I didn't make out what that means. How to find the positive pressure maintained in OT or BMT as per design? Is Yusuf Ali...
That is what he actually wants to mean. The positive pressure. Now this is, I'm giving an answer.
Yeah.
You find few of the consultant contractor use a negative pressure. Even in the I finding some journals also that some using the negative pressure. There is no negative pressure. This negative pressure concept came after the COVID. This should be actually, it will be used called isolated low pressure isolated room. You cannot keep somebody in a negative pressure. How a negative pressure develops? Your supply pressure is less than your exhaust, so naturally there will be a vacuum. It's a low pressure.
Yeah.
It is not good. Now how to maintain a positive pressure means all positive pressure. I'm saying my design is 25 Pascal. So I've explained you that in between the wall, that this there is a K factor that a consultant to be considered in the design. What type of equipments, instruments are there? What will be the loss of pressure? Accordingly, a CFM to be designed to maintain. There's a total engineering calculation. How I will maintain a 25 Pascal, because pressure is depending on CFM. That I show you that calculation. But there is a K factor is also there. So it has to be considered a K factor to have an accurate design pressure.
Okay, I think it's time for us to stop. And there's a email. Everybody can, whoever wants any more queries can send a mail to TG support so that this will be all passed on to Mr. Niladri. So I think the time is up, and thank you everyone for attending. Thank you very much, Niladri, and I'm sure we can arrange separate sessions for the
Because,
TRR.
madam, there
Yeah,
is a
yeah, yeah.
question, some mail came to me for that TRR. How will incorporate in cardiovascular surgery, HVAC design?
Yeah,
It's a very lengthy subject.
correct.
So if we get an opportunity, we can have a separate subject on TRR incorporation in a cardiovascular surgery room.
Yes,
Is an
yes.
HVAC support.
It could be like a training program rather than a 1 hour webinar. I mean, you can't cover too much in 1 hour. You require more
Right, like
time.
it's a BMT room, which I have explained. It is not that easy. It's a difficult
Correct,
job.
correct. So it requires a proper, maybe a few hours training, maybe online or offline. So we can,
That also we can do. It is more than
yeah,
2 hours or something. Many
yes,
students and consultant can join.
yes. So
We
we'll,
expect that more HVAC consultant join. It will be good.
yeah. So we'll convey that to ITC so that we can arrange more
Correct.
webinars from you.
Both for
Okay.
this critical design like BMT room
Yeah,
and this
yeah,
cardiovascular surgery room
correct.
of the TRR, incorporation of TR, this one.
Yes. So
This is
we'll
a subject
convey
actually,
this to,
cardiovascular thoracic surgery room,
yeah.
HVAC design.
Yeah. So we'll convey this to ISHRAE ITC and possibly we'll arrange separate sessions for
Yeah,
this.
right,
Okay.
correct. Thank
Yeah.
you.
Okay. Thank you very much, Mr.
Thank you.
Niladri.